Season 2, Electromagnetic Spectrum, Episode 32, Refraction and Total Internal Reflection, TIR. Did I say Physics in Necrotic World? Physics in Necrotic World. Episode 32, Refraction and Total Internal Reflection. I think I'm missing something. What do I normally say? Season 2, Electromagnetic Spectrum, Episode 32, Refraction and Total Internal Reflection. Is there something else I normally say? Well, I'm just gonna stop. Yeah. Welcome, strangers. I feel like there's something I'm forgetting. Hang on. What do I normally say? I do the season. I do the episode. No. I do the season. I do Physics in Necrotic World. And then I do the episode. Season 2, Electromagnetic Waves. Physics in a Necrotic World. Episode 32, Refraction and Total Internal Reflection. Welcome, strangers. There's a lot of content to talk about with refraction. So how to start? When we change the medium the wave travels in, you change the direction and speed of a wave. This is called refraction. Wave speed is frequency times wavelength. A boundary is crossed by a wave, so there is a refractive index difference. Speed is directly proportional to wavelength. Frequency is constant, regardless of medium change. Wave fronts are transverse waves. They are perpendicular to the direction of energy transfer, and these guys represent the width of the said wave. A wavelength is the distance between wave fronts. Snell was a guy who made a law to do with refractive indexes. This can be rearranged as required. As all equations can be rearranged as required. The incident refractive index multiplied by sine of the incident angle is equal to the refractive index of the refracting medium multiplied by the sine of the refracting angle. Sine means slicing, so it's horizontal. Cos means crushing, so it's perpendicular. Horizontal as in parallel. Perpendicular as in smash through it. Yeah. Tan is the ratio of sine over cos. For the record, no one is sinning. It's just sine being applied. N, capital N, represents the refractive index. So N is C over V. V represents velocity. C is for speed of light. From Einstein's equation. Apparently it's really famous. People have it on their t-shirts for some reason. E equals mc squared, yeah? Another formula derived from Snell's law. Wait. So why did I say E equals mc squared? Oh yeah, C is for speed of light. Another formula derived from Snell's law is capital N is 1 over sine of critical angle when original medium is air. Capital N is given by sine of the incidence angle, so sine I. So sine I is sine of the incident angle over sine R. So sine of the angle of refraction, not reflection. Critical angle is inverse sine over. Wait, hang on. Critical angle is inverse sine of 1 over n. The practical for this is drawing around a semicircular block on plain paper. Then you take the block off the paper to draw a nice normal. The normal should be perpendicular to the surface. Put the block back and shine the light at the normal. Those colourful ray boxes are really fun, yeah? So you draw a ton of crosses on the incident ray and the final ray. From the normal, you measure the angles. It's always measured from the normal. All angles measured from the normal, yeah? Generally measured from the normal. The independent variable goes on the x-axis, which is the angle of incidence. The dependent variable goes on the y-axis, which is the angle of refraction. Total internal reflection is when the light reflects completely off the inside surface of a material. The critical angle is where light leaves parallel to the surface. The angle of incidence leads to the 90-degree angle refraction, so following along the seafloor of the circular block. TIR only works when light is shone past the critical angle. If it's less than the critical angle, then light just refracts. The wave always follows the rules. The big one is the law of reflection, where the angle of incidence is equal to the angle of reflection. Not refraction, but reflection, because it's a law of reflection. So, think of mirrors. I mean, to be fair, you can think of mirrors with refraction too. But refraction makes me think of bendy straws. The smaller the critical angle, the easier it is to avoid data loss along a fiber optic cable, as it's allowing for greater total internal reflection. TIR is total internal reflection. Not refraction, but reflection. That's confusing, right? I mean, not really. But there's two different R words with... I mean, I don't mean like a swear or anything, sorry. No, I mean like reflection or refraction. Fiber optic communication use TIR on a regular basis as information is carried along your thin, plasticky, kind of solid fibers. I think they're very colourful with their multiple colour code systems. Repeatable experiments are when the same guy repeats the same experiment at least 3 times with the same method. Then this guy announces to the world that they're a budding genius. Sure, why not? So the world answers. Well, someone in the world who's interested answers and reproduces the experiment as a different guy, a different method, with perhaps different equipment, but the same sort of, well, similar experiment, because they're trying to figure out the same sort of thing, right? See you next time at Physics in the Necrotic World. This is your host, Rimona Christian, out.